So welcome back to module number 6, correlation and experimentation. So our learning targets for today will be to explain what it means when we say that things are correlated, understanding the differences between positive and negative correlations, understanding illusory correlations and the concept of regression toward the mean, and understanding why correlations enable predictions, but not cause and effect. Correlations do not equal causation. That will be said over and over again in this course. And also describing the characteristics of experimentation that make it possible to actually isolate cause and effect. So what does it mean when we say two things are correlated? Well, correlation is a measure of the extent to which two factors vary together. And this allows prediction. So how well each factor predicts the other factor. So for example, if we look at the instances of lung cancer and the prevalence of smoking behavior, we could see that there's a correlation between smoking and lung cancer. As individuals smoke more frequently, the incidence of lung cancer happens more frequently. If we look at study skills and GPA, we may say there is a correlation between studying and strong grades. As individuals study more, there's a tendency for them to have higher grades. Of course, none of these correlations are, usually ever perfect correlations. So how about the difference between a positive correlation and a negative correlation? We have to be careful with these terms because sometimes we think positive, negative, good, bad, but that isn't what it means in this instance. So a positive correlation means that two sets of data tend to rise or fall together, such as college graduation and income levels. Those who complete college tend to earn more money. So as your completion of college rate goes up, your tendency to earn money goes up as well, and earn more money goes up as well. On the other hand, a negative correlation means that one set of data rises while the other one falls, such as age and amount of nightly sleep. As we get older, the amount of sleep we get tends to fall. So let's do a little bit of a comprehension check of what we just went over, because this concept of positive and negative correlation is extremely important to understand. So which of the following is an example of a negative correlation? People who spend more time exercising tend to weigh less. Teenage females tend to have fewer speeding tickets than teenage males. Students with lower IQ scores tend to have lower grades. As hours studying for a test decrease, so do grades on that test. Students' shoe sizes are not related to their grades. Okay. The only one that really seems to make sense as one goes up, the other one goes down, is that A, people who spend more time exercising tend to weigh less. So as one variable, time exercising goes up, weight goes down. So that would be the only example there of a negative correlation. How do we measure correlations? Well, we use a correlation coefficient, which there's several different ones. Most often used is the Pearson product moment correlation. A correlation coefficient is a statistical index of the relationship between two variables. Variables that are positively correlated are measured. So R is usually the term that we're using when we're talking about correlation in statistics. And R ranges for positive correlation from 0.01 to 100% correlated would be a value of 1. Variables that are negatively correlated are measured from R equals negative 0.01 to variables that are perfectly negatively correlated would be negative 1.0. Note that correlation coefficients are expressed as R values. And also note, it's not noted on this slide, but if two variables are not correlated at all, the value would be 0. So what is a scatter plot? It's often used within research, within psychological studies all the time. And it is a graphed cluster of dots, each of which represents the values of the two variables. The slope of the point suggests the positive or negative direction of the variables between the variables. The amount of scatter suggests the strength of the correlation. Values on the X and Y axis must be quantified. So here's an example. What does a positive correlation scatter plot look like? So this would be a perfect positive correlation. The variables increase together or decrease together. If one gets larger, so does the other. So on each axis, as it goes up one way, it goes up on the X, it goes up on the Y, and it would be perfectly correlated. The slope of the line goes up from left to right. So how about a negative correlation scatter plot? What would that look like? Well, kind of almost the opposite. As one variable increases, the other one decreases. If one variable gets smaller, the other one gets larger. This is an example, which doesn't happen very often, of a perfect negative correlation, and r equals negative 1.0. The slope of the line goes down from left to right. Now, what would a scatter plot look like if there was no relationship between two variables? Something like this. As one variable increases or decreases, the other one increases or decreases randomly. There's no real relationship between the variables on the scatter plot. As one goes up, sometimes one might go up, or sometimes it won't go down, or vice versa. What is really important to remember about correlation coefficients? So a correlation coefficient, which can range, again, remember that perfectly negative correlation of negative 1.0 to a perfect positive correlation of 1.0, reveals the extent to which two things are related. The closer the score gets to positive 1 or negative 1, the stronger the correlation. The positive or negative sign before the number just tells you whether or not the correlation is positive or negative. Not that you should be judging it as a good thing versus a bad thing. It indicates direction, not any sort of value. Okay, so I want you to do a little comprehension check and try it. Which of the correlation coefficients below expresses the strongest relationship between two variables? So your first instinct might be to say, oh, wow, positive 0.76 is the largest number in value. But actually remember, when we're talking about correlation coefficients, they go from negative 1.0 to positive 1.0. And so the strongest correlation right there would be the negative 0.91. 1.2 is not an acceptable value because it's over 1. So negative 0.91 would be the strongest correlation, and it would indicate a very significant negative correlation between two variables. So what is the concept of illusory correlations? We see these all the time in our everyday lives. Perceiving a relationship where none exists, or perceiving a stronger than actual relationship. So for instance, a sports fan wears a blue jersey the day her team wins, and she decides to wear that blue jersey on game days from now on, although the jersey had no real impact on the score. I may or may not have been guilty of things like this when I played high school soccer and college soccer. We see a relationship where none exists. What is regression to the mean? The tendency for extreme scores or events to fall back toward the average. So for instance, an athlete has an amazing game and performs extremely well. In subsequent games, the athlete returns to his normal performance. Or a student scores much lower than normal on an exam, and on future exams, the student scores return to their average. I always think about the concept of regression to the mean at restaurants when I have an absolutely fantastic meal at a restaurant a couple times. There's a tendency for the next time, the third or the fourth time I go back, that it's going to be more of an average meal. We're going to regress back to the mean in terms of my enjoyment of the meal. So how do correlations help us to predict events? Correlations do help us predict. So self-esteem correlates negatively with, and therefore predicts, depression. So as self-esteem goes up, their levels of depression go down, and vice versa. The lower people's self-esteem, the greater their risk for depression. So possible interpretations could be one of multiple things. Low self-esteem leads to depression, depression leads to low self-esteem, or some other third factor, such as some sort of distressing environmental event, or a predisposition, a genetic biological predisposition that both are affecting, or a couple different factors. This illustrates what's so important about correlations. We know there's a relationship, but we don't completely understand the relationship with just the information from a correlation. One thing could cause the other or vice versa, or there could be something else that is causing both of the variables to move. This is one of those things. This statement, correlation does not imply causation, is one of the most important things I hope you take from this psychology course. That just because two variables are correlated does not mean that one variable causes another. It simply means that they are related and they vary together. They can vary either positively or they can vary negatively. So mental illness correlates with smoking, meaning that those who experience mental illness are also more likely to be smokers. Does this tell us anything about what causes mental illness or smoking? No. There may be something about smoking that leads to mental illness. Those with mental illness may be more likely to smoke, or there may be some other third variable, such as a stressful home life or something completely, we're not even thinking about that triggers both smoking and mental illness. Some other third variable that's often really hard to identify could be the causal factor for both of those things, both mental illness and ending up smoking. Again, correlation does not prove causation. Length of marriage, and there's some really interesting examples and silly examples we can think about with this, but length of marriage positively correlates with hair loss in men. Does this mean that marriage causes men to lose their hair, or that balding men make better husbands? Of course not, right? There's probably some other factors like length of time you're married and hair loss happening that really are the causal factors there. So here's a little AP exam tip if you decide to take the AP psychology exam. Take note of how much emphasis is put on this idea of correlation and association not proving cause and effect. This is a very, very important concept within psychology courses. Correlation does not imply causation. Okay, so how can experiments establish cause and effect? If we know correlation does not imply causation, well, how do we come up with causal factors? What do we need to do as scientists? Well, we use experiments. Experiments enable researchers to isolate the effects of one or more factors by manipulating the factor of interest and holding constant or controlling other factors. So what would be an example of an experiment that could show cause and effect? Well, does breastfeeding lead to smarter children? So the breastfeeding would be the cause and the effect would be smarter children. And remember, talking about operational definitions, we have to really define what these variables would look like for our particular experiment. So this experiment was actually done, and it's been done a few times, but we're talking about one specific instance of it. So within this experiment, how are the groups assigned? Well, the experimental group, subjects received the treatment. The pediatricians promoted breastfeeding to mothers in their group. The control group, subjects did not receive the treatment. The pediatricians provided normal care, but did not promote breastfeeding. How was the experiment conducted? Well, in the experimental group, at 3 months of age, 43% of babies were being breastfed. And in the control group, at 3 months of age, 6% of the babies were being breastfed. Well, what were the results? At age 6, when nearly 14,000, this was a pretty large study, 14,000 of the children were restudied, those who had been in the breastfeeding promotion experimental group had intelligence test scores averaging 6 points higher than their control condition counterparts. And this was a significant difference between the experimental and control group. So that would be how an experiment could and has been done. What is random assignment? Assigning participants to experimental and control groups by chance, thus maximizing pre-existing differences between the different groups. Okay, so what does this mean? Let's think about that. Assigning participants to experimental and control groups by chance. So using something like a table of random numbers or even the flip of a coin. It has to be a chance whether or not people are going to end up being in the experimental versus the control group, because that is how you can minimize any sort of pre-existing differences between the experimental and control group. Why does random assignment help establish cause and effect? Well, what if all the babies in the experimental group shared one specific trait that influenced intelligence? We have to control for confounding variables such as parental intelligence and environment in the aforementioned study. In order to control for confounding variables, experimenters must randomly assign subjects from the population or from the sample to the experimental and control group. So what's the difference between random sampling and random assignment? Well, random sampling is choosing a representative sample of the population being studied. It allows the results to be generalized to the population as a whole. Whereas random assignment in an experiment is assigning the participants to either their experimental or control group by chance. So again, you have to use some sort of method to assign people or individuals to different groups. It has to be like a table of random numbers or a statistical program or even flipping a coin that you use to assign individuals to experimental or control groups. So how does using a blind procedure help establish cause and effect? And this means that either the individuals in the study or both the individuals in the study and the researchers don't know who's in which group. So in a single blind study, the participants in the study are uninformed about the treatment, if any, they're receiving. This controls for subject response bias and the idea of the placebo effect. In a double-blind study, the participants and the researcher are both uninformed about which group receives the treatment and which does not. This controls for experimenter and subject biases as well as the placebo effect. Because there's lots of different influences that can happen. Even like researchers that are the most well-meaning, they can inadvertently influence the results of a study if they know who is in which group. So what would you answer? In a drug study, neither the participants nor the person distributing the pills know who is receiving the new drug and who is receiving the placebo. The placebo is the, we're going to talk about in the next slide, it's sort of like a fake treatment. This type of research design is said to be this would be a double-blind study because neither the participants nor the person distributing the pills knew who was receiving the new drug. So what is a placebo? A placebo is an inert treatment like a pill without any medication inside. The placebo effect causes experimental results simply from the expectations. There's so much very fascinating research out there about placebo effects within psychological and medical literature. That just the mere expectation of an effect can cause an effect in a lot of cases. And this little cartoon here, if I don't think it's going to work, will it still work? Okay, so let's look at some of the research on the placebo effect, which is fascinating. Athletes have run faster when given a supposed performance-enhancing drugs. Just being told they were being given a drug that would make them run faster actually made them run faster. Decaf coffee drinkers have reported increased vigor and alertness when they thought their brew had caffeine in it. People have felt better after receiving a phony mood-enhancing drug. There are so many examples, and there's a tendency if a placebo costs more, or if it's something that's like injected into you rather than swallowed, those different things make the placebo have an even stronger effect, which is so fascinating. So what is the difference between an independent and dependent variable? We're talking about research studies in psychology. Well, the IV, the independent variable in an experiment, is the factor that's being manipulated, the variable whose effect is being studied. The independent variable is given only to the experimental group. The dependent variable is the outcome. It's in an experiment, the outcome that is measured, the variable that may change when the independent variable is being manipulated. The dependent variable measured is in both groups, both the control and the experimental group. So here's another AP exam tip. The identification of the IV and DV is the single most likely concept to be tested on the AP exam. This is really, really important to understand. The difference between the independent variable and the dependent variable, and being able to identify them within examples. Experiments are critical to psychology, and IVs and DVs are critical to experiments. Remember to use operational definitions to quantify variables if you end up taking the AP psychology exam. So consider these hypotheses from Module 5. Identify the IV and the DV in each instance. Music helps plants grow. Well, the independent variable would be music. If you applied some sort of music to the experimental group of plants, but not the control group, the music would be the IV and the plants would be the dependent, or the growth would be the dependent variable. Ginger tea helps reduce hyperactivity. Well, the T would go to the experimental group, but not the control. And the measurement of hyperactivity would be the dependent variable, with ginger tea being the independent variable. How about eating junk food causes weight gain? Well, the independent variable would be eating junk food and would be applied only to the experimental group. And the weight at the end of the experiment would be the dependent variable or the outcome variable. What would you answer on this question? In an experiment to test the effects of room temperature on test performance, the independent variable is, it should be room temperature, D. The temperature of the room would be the independent variable, what you are going to be manipulating and giving to the experimental and not the control group. So what is a confounding variable? A factor other than the factor being studied that might influence a study's results. The key is that some unique factor must be present in one of the groups. but not in the other. A variable cannot be confounding if it occurs in the same degree in both groups. So how we combat this as scientists, this idea of confounding variables, is to utilize random assignment to experimental versus control groups. So what are some typical confounding variables that can happen? Age, intelligence level, ethnicity, sex, political beliefs. If you have an experimental versus a control group, you want to make sure you have a distribution of each of those within both of the groups that is very similar. Otherwise, it could end up being a confounding variable. What is experimental validity? It is the extent to which a test or experiment measures or predicts what it's supposed to. For example, if you're taking a driving test and pass it, we should expect to see accurate driving skills from you. Is that test actually measuring what it purports to measure, that you're going to be a good driver? The driving test would be considered a valid measure of your ability to drive. So let's do a quick review of our learning targets from the beginning of this module. Explain what it means when we say two things are correlated, and describe positive and negative correlations. Correlation is the degree to which two variables are related and how well one predicts the other. It does not imply causation. In a positive correlation, two factors increase or decrease together. As one goes up, the other goes up. In a negative correlation, one variable increases as the other decreases. Next learning target, explain what it means when we say two things are correlated and describe positive and negative correlations. So in psychology, we use a correlation coefficient, and it's a statistical measure that describes the strength and direction of a relationship between two variables. This can go from +1 through 0 to -1. The relationship may be displayed in a scatterplot, which is a great visual way to see the relationship between two variables. Explain illusory correlations and regression toward the mean. Well, illusory correlations are random events that we notice and falsely assume to be related, like a tendency for bizarre behavior when there are more full moons. There are lots of different reasons why we can see illusory correlations, where we just are drawn to relationships between things and we want to find patterns in nature. But there's lots of times that we get tripped up by this idea that things are correlated, when if we actually took counts of how many times they were happening, it would show that there really isn't a relationship between two variables. The concept of regression toward the mean is a tendency for extreme or unusual scores to fall back toward their average. Next learning target, discuss why correlations enable prediction but not cause-effect explanation. Well, correlations allow prediction because they show that two variables are related. So as one goes up, the other goes up, or as one goes up, the other one goes down. So there's a relationship there of some sort, but we do not know what the cause is. And it could go in either direction, or there could be some other variable or variables that are causing each of the variables to move up and down. Correlation can indicate the possibility of a cause and effect relationship, but it does not prove the direction of the influence or whether an underlying third factor may explain the correlation. So describe the characteristics of experimentation that make it possible to isolate cause and effect. To discover cause and effect relationships, psychologists must conduct experiments, manipulating one or more variables of interest and controlling other variables, and using random assignment to minimize confounding variables, such as things like pre-existing differences, between the experimental group and the control group. And finally, our last learning target for this module, describe the characteristics of experimentation that make it possible to isolate cause and effect. Well, the independent variable is the factor manipulated to study its effect. So in the music and plant growth, if we played music for the experimental group, but not for the control group, and we then found that those plants that listened to music grew much faster, we would say that there was an effect of the music on plant growth. The dependent variable in that study would be the growth of the plant. The dependent variable is measured to discover any changes occurring in response to the manipulation of the independent variable. The idea of a double-blind procedure is used to avoid placebo effect in researcher or subject bias. And we say that an experiment has validity if it measures what it purports to measure. Does the experiment kind of get at, is it valid? Is it measuring what you're saying that it's actually measuring? Okay, that's it for today. Thank you for listening. Take care.